Hey Cloud Gurus, and welcome to Azure Service Spotlight. I'm Daniel Stinchcomb, and today we're going to talk about Azure SQL Database. Data is debatably the most crucial part of any environment. Everything we build and do is meant to store, consume, and create more data. The technologies we use to manipulate that data come in all shapes and sizes, and can range from truly great and robust solutions like Azure SQL Database to complete abominations that have been the bane of many a database administrator. Here's looking at you, Access. Azure offers many great solutions for managing your data and has even gone so far as to develop solutions for competing platforms, such as MySQL and PostgreSQL, just to make sure that customers have the flexibility to see how inferior those products are before switching to Azure SQL databases. I'm just kidding. I'm sure those products are great, or at least they will be one day. Businesses these days need their data to be more resilient than ever, and the software they choose to store that data needs to be scalable and performant, regardless of whether it's being used by a small office, a whole region, or even the whole world. Azure SQL Database gives companies the ability to check all those boxes while keeping their focus entirely on developing their application and database code, as it removes the need to manage the hardware and service layer to keep your DBA from arguing with your SAN administrator for more space, or constantly needing more RAM because databases simply need all the memory. I'm sure most of you are thinking this is just SQL Server in the cloud, right? Well, yes and no. When you use Azure SQL Database, Microsoft creates a logical SQL Server that acts as a central administrative point for your databases. Your databases aren't necessarily stored in the same location as your logical SQL Server, as it functions almost exclusively as a control mechanism, rather than the traditional SQL Server instance you may be used to. So while Microsoft does consider Azure SQL Database a platform as a service, or PaaS, offering, this can be viewed more like a database as a service offering, or DBaaS. So what makes Azure Database special? Well, let's break it down. Azure SQL Database is all about 4 main features that set it apart from other relational database platforms in the Azure ecosystem. Those include your system and service configurations being handled by Microsoft so that you can worry less about patching and more about optimizing your code or watching internet videos. Nah, don't judge. Additionally, you get scalable storage, which can be extended into multiple terabytes that can also be ran at Hyperscale, which is a really cool feature we'll dive into shortly. Another feature, while you can choose your general performance tier at creation time, you can utilize AI-controlled scaling on the back end through a serverless cost model, which tries to keep your bill down by only using all your billable resources as necessary. This makes it so while you can plan for using all, say, 36 of your vCPUs, if it's not needed, Azure will tune that down to utilize only what's necessary when maximum power isn't needed, to keep maximum billing at a minimum. The final feature I want to cast some light on kind of fits with that whole PaaS thing, but it's worth mentioning because Azure really does do a great job of making things like identity and network access a breeze. Using the built-in firewall features and even Azure AD, you can easily control who or what can access your data and from where within just a few clicks. So why is any of this important? I mentioned before this functions as a PaaS offering, which means that there's very little for you to do in terms of configuration and maintenance. Looking at Microsoft's shared responsibility model, we can see that under the PaaS offering, all you have to worry about is your data, who can access your data, and how. The rest is handled by Microsoft. This includes patching, backups, recovery, and just general maintenance. However, you do have some control in the sense of being able to modify things like your point-in-time restore retention and adding additional backups, such as weekly, monthly, or even yearly long-term retention copies for things like auditing and compliance. But possibly the most valuable thing Microsoft does for you is that by removing the need to manage things like updates, you're always on the latest stable release of SQL Server, making it so you always have the latest security features, bug fixes, enhancements, and you'll never have the headache of losing support from product end of life. Now, looking at storage and performance, while being able to dynamically scale both either manually or with the use of AI, one of the defining features of Azure SQL Database that sets it apart from the competition is Azure Hyperscale. Azure Hyperscale makes it so your databases can grow up to 100 terabytes, gives you near instantaneous backups, regardless of size, and with little to no impact on your compute, in addition to unreal restore speeds that Microsoft claims can happen in minutes. Again, regardless of size, rather than hours or even days. Ever tried to restore a terabyte database on a local system? Huh, not fun. It takes time no matter what kind of resources you're packing, so this is a game-changing feature for businesses who need large datasets ready to go rapidly. Of course, with a name like Hyperscale, that also comes with significant performance increases as well, making it so you can quickly deploy read-only secondaries for offloading read performance, but also rapid scale up if you need a boost in power. Now, all this certainly doesn't come for free, especially when you consider services like Hyperscale. Luckily, Microsoft offers a couple of billing models to help with your needs. Like with most things in Azure, your cost is generally determined by the amount of resources you consume. However, with Azure SQL Databases, you have options that can help keep your costs within reasonable margins. The first thing to consider is your pricing model. SQL Database offers 3 different models you can use to best match your billing needs. You can purchase database transaction units, or DTUs, adopt a vCore model, which is more of a pay-as-you-go approach, and then there's also working with Serverless, which is more of a pay-for-what-you-use by the second approach. DTUs, which are essentially pre-packaged compute, storage, and I/O amounts that you utilize in your instance. The more DTUs you purchase, the more you pay, since the cost per DTU is a fixed unit. This is handy for when you have predictable workloads, such as standard OLTP databases for things like your line of business applications or smaller workloads during set business hours. That's not to say you can't use DTUs effectively for more ad hoc or 24-hour constant workloads, but the returns start to diminish in these scenarios. DTUs can also be effective for elastic pools, where you have multiple databases taking resources from one resource pool, in which case you would call these eDTUs, and it's essentially the same thing. The primary difference is that you can add or subtract DTUs in an elastic pool with no downtime, which makes it so you can budget your resources accordingly. Meanwhile, you can use the vCore model to get the more traditional pay-as-you-go approach, as you'll select from a variety of performance tiers and pay based on the amount of time your server is operating at that level and any storage you consume. This is extremely useful for less predictable workloads, as it allows you to better plan your monthly billing, as your own shifting cost is really just your storage. Microsoft has taken the vCore model one step further, however, with a serverless offering that allows you to select a performance tier like the vCore model. However, your instance will only operate and be charged for the resources in use. So if you select 36 vCores in the business critical tier, but you only use maybe 2 or 4 of those vCores in off-peak hours, you're charged at a lesser rate, making it so you can rest easy knowing you're truly only paying for what you need. Now, this is less predictable if you have inconsistent workloads, ad hoc operations, or if you're frankly just not sure, so your mileage may vary with how much savings this will actually net you. In addition to all that, you can take advantage of the Microsoft Hybrid benefit. This means that if you already have licensing for SQL Server, you can bring your license to Azure and not have to pay for the SQL Server license, which can be costly by itself. So I'm sure some of you are wondering at this point, Daniel, what the heck does this look like in action? Well, let's poke around the surface a little. So here we are on the resource group page, and I'm just going to add a resource and click SQL Database here on the Add a Resource page. I'll fill out the information here on the Create SQL Database wizard. I'll give my database a quick name. And then also something to mention is if you don't have a SQL managed instance, it is a requirement for this, but all you got to do is click Create New Server here, and you can just fill out the information in this blade to spin one up real fast. A SQL managed instance generally isn't going to run up your bill too much. It's the databases inside and the resources it contains that are going to cost you anything. So we have our server created. I have the option of selecting if I want to add to an existing elastic pool, possibly even create one. Here, I can decide what compute tier I want to start off at. I can select my pricing model between provisioned or serverless, as we went over earlier, and then I can also look at things like hyperscale, business critical, or lesser environments if I so choose. I can scale up my vCores, and this is where I can apply my SQL Server license if I've already got one that I'm bringing to the table. Here we can configure if we want to use an existing data source. I'm going to go ahead and do the standard AdventureWorks sample database. I could also use a backup if I wanted to. Now, you've also got the option for security, but we're not really too worried about that right now because Azure Defender is kind of a new product, and I'm sure we'll go over that in a future spotlight. As always, we'll review our settings, and I'll just click Create here. Now, this takes a moment, so I'm going to go ahead and fast forward, and we'll pick up after the database has been deployed. The deployment's complete, so let's go browse around the SQL database overview. Here on the overview page, we can see our new database and all its stats. So we can see what our compute utilization looks like, we get our general overview, we can add to this if we really want to, but for right now, let's take a look at some of the features that we can play with. The first thing we want to do is set firewall rules. Now, firewall rules are important for any PaaS because these are what allow you to connect. In this case, we have the ability to deny public network access, set a TLS version if we have some type of compliance minimum. The biggest thing you'll want to do in any PaaS solution is always make sure that you can connect from wherever you're working from. In my case, I'm going to enter my client IP address from my home. I'm going to click Save, and that'll add this to the Managed Instance Firewall. Now, I want to be clear here, these are set on the Managed Instance level, not the database level. So, you'll want to keep that in mind when you're setting your rules for access to your databases. We can see here that my IP address has been added successfully. We can also add virtual networks if we wanted to, but for now, I'm just going to go back to the resource page. So now let's run a quick query. You have two options when it comes to running queries. You can use either a standard tool like SQL Server Management Studio or Visual Studio Code, or you can use Azure's new query editor here in the browser. Now, in the browser, you have two options to connect. You can use Azure Active Directory Authentication, which we haven't set up yet, but you can set up, or you can use the local administrator account you set up back on the SQL Server Wizard. Once connected, the SQL Query Editor gives you a pretty standard query editing window. You can browse your tables, you can look at views and stored procedures, run any standard T-SQL type queries from this browser window. In this case, I'm just going to select a top 1,000, and you can see here that the query does take a little bit of time to run. Now, I will say that the query editor does take just a little bit of extra time. So something like this, that would probably run in maybe less than a second in your standard environment, is going to take a little bit of time to return in the browser. Now, if you want to have a more robust feature set, you want to be able to use IntelliSense, you want to be able to actually connect and have your queries return in a faster method, we can use one of our own IDEs, in which case I'm going to use Visual Studio Code. So I'm going to go ahead and add a connection real quick. And once I've added my connection, I can view all the tables here. I can run that exact same query from the query editor before. Just select a quick top 1,000 from the customer table, and you're going to see this returns a lot faster, despite the fact that it's coming from a remote source. So we'll go ahead and close this out. Now, something else we can do too is we can also set up georeplication, which from the database layer is effectively creating a copy of our database somewhere else. So we can either create a copy locally, we can spread it out somewhere else. In this case, I'm going to select Central US. The second database will be readable, so it'll be something that you can use to offload queries either for reporting or possibly just for being able to consume datasets without impacting the resources on your production server. We'll fill out some basic information such as the new server name, because again, this will require another managed instance to be set up in the new area. We'll give it an admin login and passphrase. And then we'll of course set up the compute tier. Now the compute tier does have to be similar in the same range, but you have a little bit of flexibility if you want something that's a little less powered since it's a read-only copy, or maybe something more powerful so that it can facilitate more reads. The status here will show that it's initializing, and from initializing, once it's done deploying the managed instance, you'll see it change to seeding. as it'll be setting up the new database over in the central US region. This takes a little bit of time, just like any other deployment. So I'm going to skip ahead a little bit, and you'll see now the database is seeding. And that seeding, of course, will give you a small percentage if it's a larger database to give you an idea on where it's at in the process. But skipping ahead further, we can see now we have a live copy sitting over in the central US. So now that we've covered setting up a replica database, let's see how we can scale up our performance tier. Over here under Settings, we'll select Configure, which will take us back to the Performance tier selection page. You'll notice that some options are unavailable, and that's due to our replica. Since we're replicating our database, we'll need to stay within the same tier. However, we're still able to expand things like storage and vCores as necessary. All of this has been set up in mere minutes. That is extremely difficult to do with your typical SQL Server setup. So it's worth keeping in mind as we continue along our evaluation of this product.
So let's lay things out and make a decision on if this service is for you. For something like this that is so highly nuanced, let's break down some of the pros and cons. On the pros, we have a great deal of flexibility in our database sizing and performance options. This is huge when you consider the pain and risk of reconfiguring an existing SQL Server instance versus the ease of a few mouse clicks as we saw in our demonstration. Additionally, it's much easier to secure and manage your databases since your main security concern is just who and where, rather than, well, everything. You're responsible for all of it. I mean, don't you like sleep? The possibility of cost savings is another big one, given the number of billing models available to you. It's easy to see how you can better control or even reduce the cost overhead in running your database in Azure SQL Database when you consider administrative time, power, resource comparisons, etc. The list goes on. It really is cheaper if you take the time to quantify the time and energy necessary to manage an instance you build yourself. Of course, one of the biggest items in the pros column is that you're always up to date. Not needing to patch, maintain, or worry about versions is a huge relief for many an administrator and saves a tremendous amount of time. With all this, of course, there are things you need to consider in using a PaaS service. On the con side, I have to call out the lack of control. I know. I pitched that as a pro just a moment ago, but hear me out. There are many times when it's important to be able to fine-tune your instances to get optimal performance out of application databases, or even for really stringent compliance reasons. Sometimes a PaaS solution just doesn't offer the control you need. Now, don't let lack of understanding hold you or your grouchy DBA back. Simply understand what you're sacrificing in terms of control and make a plan for how you and your company can deal with it. Additionally, while you can save a ton of money with this service, costs can also get out of hand really fast if you're not paying attention to your needs and scaling appropriately. While it may make sense to run at the highest performance tier during peak hours, scaling back down on non-peak hours is where the cost savings really comes in, but only if you are using something like the service model or if you scale back yourself. Billing is an important topic in Azure, so make sure you understand regardless of what technologies you're using. The potential for code or feature deprecation is another thing to watch out for. Being on the latest release is a double-edged sword, as that means it's on you to ensure your code is always taking into account updates or removals that can break your application. This isn't a massive worry, as there's been speculation that Microsoft is going to remove things like SP, MS for HDB since 2008. And yet here we are in 2020, and hey, it still works. Neat. Then of course, we have to consider the compatibility with your existing infrastructure and applications. Compatibility is a big thing to consider when you're choosing a platform, and with Azure SQL Database, you absolutely need to be sure your third-party applications, existing systems, and developers will support this choice. This isn't just database compatibility level I'm referring to either. This means your connection methods to whether your application needs to be able to build its own databases. You need to consider the hoops you'll need to jump through, or if it's even possible. So with all this under consideration, what's my final verdict? This, to me, lands firmly in the evaluate column. While it is a fantastic relational database management platform, I'm a firm believer in using the right tool for the right job. And SQL Server, much less a more constrained SQL Server, isn't always the right fit in normal situations. So I can't tell you to go all in on this no matter what. Like with most services on Azure, you need to know what you're getting into and figure out if it's the right service for you. Most cloud platforms have services that are no-brainers, such as Azure Active Directory. If you're in Azure, it just makes sense. But this product, while truly great, does require some time and research to move into your environment properly. That, my friends, was a long video. I hope you're still with us here at the end and that you enjoyed this dive into Azure SQL Database. Perhaps you have some thoughts you'd like to share on how you're using this technology in your own environment. Maybe you want to share a buyer beware story. Even if it's just some feedback on these videos, we'd love to hear from you in the comments. So, drop a comment below, like this video if you enjoyed it, and hit subscribe to get updated when a cloud guru posts more great content like this for your learning pleasure. That's all for this spotlight. I hope this video has been helpful to you, and we hope to see you back on our next episode. Goodbye, and as always, remember, stay awesome, gurus.